Okay, good morning again. Everybody, please let's go to page number 45. And this is where we finished yesterday. If you remember, we talked about different possibilities. Imagine that we have x2 like this, and we grab one part of it. I remember that Harlan was the one that we talked about different scenarios, right? If I'm not mistaken. You said, for instance, imagine that my apologies, we need to go to page number yeah, 47 for that. We said, imagine that we have an arrays like this, x1, 2, 3. And the difference between this one, which is an array of one, technically vector of 1, 2, 3. An array is two parentheses. Array means that we have rows and columns. We have dimensions, right? And we can just do the reshaping. And we started talking about the concatenation and splitting. This is the place that we talked. If you have just vector, you add two vectors together. It's going to be 1, 2, 3, and the next number would be 3, 2, 1, for example. It's going to be a series of numbers, the way that you see in a row. And if you add the, for instance, 99, 99, 99, there is no other way. You cannot say that, okay, please put this part on top of this or something. They are all vectors, so you can just line them off in one vector. Does that make sense? The next part is, let me just put this guy top, then it's not going to bother you, hopefully. The scenario that Harlan asked yesterday, for instance, what if we have one grid like this? If you say, I want to concatenate these two, what's going to happen? Is it going to put them side by side or one on top of the other? The default is axis equal to 0, right? But you may say, what does it mean, axis equal to 0? And that is the most challenging part compared to other languages, because when we say axis equal to 0, we expect something different. And I'm going to tell you a kind of trick. I'm going to explain a kind of trick which helps you to correctly use those. So if I have a grid like that, and I don't mention the default is axis equal to 0, and it's going to have 1, and put the other one on top of it, so stack them. And everybody try this. Say the same thing, please, and say comma axis equal to 0. Do you see any different results?
Is it because they're just single, like single dimensional arrays?
Okay. You mean that why?
Sorry.
Don't worry. For now, just please try and see if you add at the end of this comma axis equal to 0, is it going to make it any difference?
Yeah. So
Is it?
Yeah. Oh, axis equal to 0.
0.
Okay, so
Axis equal to 0, it's not going to change it. But if you say axis equal to 1, it's going to be vertically one here and the other one here too, right? So it's going to be wall to wall, neighbors wall to wall. And just check this guy would be here. So 1, 2, 3, then again 1, 2, 3, 4, 5, 6, then 4, 5, 6. again. So how about this? If you say you have something like 1, 2, 3, and you have grid, which is 9, 8, 7, 6, 5, 4, and you say vertically stack it, it's like you have one row and you want to put it on top of the data set. Something like that. Or you have two data sets and you want to merge them. Imagine that you have two classes and I have statistics based on one class. I said, I do not have enough samples to get a kind of general pattern. So let's merge two classes lists. In that case, I can simply use the stack and it's going to merge those two lists. But imagine that I try to calculate, for instance, the final mark, and I have forgotten to consider the bonus mark. For instance, then I'm going to add a. This is the column that I'm going to add in the last. This is how we are going to just use it. We say H stack. So horizontally add those columns for that specific column. Does that make sense? Huh? I just want to add one more things to guys. I don't know the others, but I know myself. People come to me say, Reza, I have issue this session. I don't feel like coming and practicing. What should I do? Always the answer is I can understand. Don't worry. I have been there. I have been at your age. And some even I got leave of absence for 1 whole year because I didn't want to study for a whole year. Understand it. But bringing guards up for the one who has no guard in front of you, it's not just you. Even today, I don't want to say one person in this very class said that I have this issue and I can just listen. I said no problem. Okay, look at this one. We have these numbers here. This is something that you can't easily find in other languages. For doing similar things, it takes lots of effort and lots of lines of code to get similar results. Look, we say I want to, okay, imagine that I don't have anything to, imagine that this is piece of wood and I want to cut it into 3 parts. How many cuts do I need to have? 2. Excellent, 2. So having 2 cuts like after 3 inches, 5 inches, right? Cut it, and I have 1 portion here, 1 portion here, 1 portion here. Everything is clear so far? Example here, it's not clear. Okay. Not a problem. I explain as much as we feel comfortable. Forget about that example. Whatever the length of this is, I tell you, I want to have a piece of wood here, which has 3 inches from the beginning. So you just say this is going to be 1 cut. And the other part is from the beginning, just 5 inches from the beginning. Does that make sense? And then you say that this is going to be another one.
So it's in reference from the starting point.
It's going to be from this. Good. I don't care about the last one, whatever it is. Everybody could find that. So it's going to be how many pieces it's going to have? 3. Right? And imagine that's the, yep.
So 3 to 5, so it's from the beginning to index 3, not including index 3. And then it's going to be, then the second x2 is going to be from the beginning to index 5, not including, but then also not including x1. And that's the second middle portion, and what's remaining is
Okay, let's split that split into two parts. First, the concept. I want to first make sure that we got this concept first. Yes, everybody? And now let's go further and understand what those indices mean. The first index is what? It's 3. It means that, hey, 0, 1, 2, but not 3 means here's the first box. So it's gonna be 3, 4, but not 5 before this. So it's gonna be 3 and 5. Does that make sense? Means before the index number 3, before the index number 5. Those are the places that you have to factor. Everybody's clear with this? And the beautiful part is this part. You split it. You expect to have 3 parts. We have 3 variables, x1, x2, x3, and it knows that. The first portion should be here, the second here, the third here. This is something that you cannot easily find any of the other languages. Only with Python. Okay.
So what is the purpose of putting x comma, like, first you have x there, right?
What do you want to split? This array. X should be split in these positions. So everybody's fine with that? As many as, but definitely not more than the number of elements that we have. Awesome. The next part, let me just show you one thing. And again, do not worry, you're gonna have all these things later. This is the first part. If you just say numpy that array range from 0 to 16 is going to be 1, 0, 1, 2, all the way to 15, but not 16 elements. But I want to reshape it, so I say dot reshape 4 rows and 4 columns. Does that make sense? So lovely, thank you. Please just make sure that you have no problem. If you want to type or if you want to copy and paste from the book. For those who want to copy paste, the page is page 49. So I think, Carla, now you can help me for this. You can help me with this. If I want to vertically, I say, okay, go down all the way to here. And also at the end, Lucas, right? So 0, 1. I want to cut before 2. Should I say 1 or 2? Excellent. What's your name, sir? Richard. Thank you, Richard. So, as you said, you say vertically, I'm going to all the way to this, and it's like that. So, number 2, that's what it says. Split it, and the first portion say there, and the second portion say into lower. So this is how you're going to see. The difference that you see here compared to the book is I just added those asterisks to make sure that you see where the division happens. Please give yourself time to try them, and if there is any concern or question, let me know.
Yes,
Still confused, in the example from the textbook where we were splitting on 3 and 5. It wasn't inclusive. But now that we're splitting on 2, it does include it.
for this one, we're not talking about ranges, you want to.
Yeah, you tell me where you're from. So it's where is it second? Oh, I'm thinking of. Yeah, we're throwing back. Yeah, okay.
Awesome. Matthew? Thank you for the help.
What if we have like, let's say, 15 numbers and we want to sheets and rows and three columns? Will it still good, like, so like number of elements we have in each row is not even, like, it's not equal often.
We can't get it. So how about that? In a few seconds, I'm gonna give some samples to friends and then I'm gonna answer that. Just look at this one, everybody. I think that we can just talk. What is your example?
So let's-
Who wants to use this and draw it here because I'm not very much good. Just draw it here and then I'm gonna just ask you to explain.
Yes, we were, yeah, I'll put the flip sheet or,
Yes. Okay, awesome. We are going to vertically split not the index 0, not the index 1, but before row number index 2. There's gonna be rows number 0 and 1. So it's gonna be just a place that we have files. Imagine that we had several rows. We could have 2, for instance, 7, 9, right? The same thing applies here when you say, let's have horizontally, guys, horizontally, we are gonna just walk. Just not to get confused, this is the place that you walk horizontally. It's not gonna be 0, it's not gonna be 1, it's gonna be before 2. So that's 2, 7, those two, the index of this one before that. So it's gonna be 0 and 1. And you are gonna save that part into the left. And if you see, we are going to have left part and right part. Does that make sense, everybody? Okay, so yeah, your question?
So I'm saying, what if we have like 7 numbers in array, but we want to reshape them like in 2 rows and 2 columns?
It's gonna give error. Simple.
Because
Yeah, sure. Because there is no way that it can say 2 and 2, right? It's gonna give error. Simple. The shape should be aligned with the number of elements that you have. So for 7, you can just have 1 row and 7 columns, or 7 rows, 1 column.
should be like a complete matrix, right?
We need to add stuff into it, like, I mean, 0 or something in order to have ability to.
So like because can it be like four elements in one row and like the rest can be like the second one?
It's not possible. It's gonna just give error as well. Okay, so you remember that we talked about the seed, and how many of you have not finished the quiz yet? So great, please first, don't forget to finish it by tonight. And if not, it's not a big deal because we can just pick 8 out of 11. But for this one, C is the thing which is responsible to unify the examples. For instance, the random numbers of Rachel and the random number of Mo and the random number of Maharshi are going to be the same if they use seed 0. But the question is,
Are we just responsible to use sig 0? We can't use any other number. Imagine that you don't
feel happy with the series of random numbers that you have. You can simply change it to 40. But if you want to have unified numbers among the team, everybody should use seed 40. Does that make sense? Huh? Okay. The other thing is, let me just make sure I haven't missed.
Imagine that whatever we are going to do in machine learning and deep learning are based on two major libraries. Guys, I'm not talking about the algorithms that we have in machine learning or deep learning. I'm talking about to bring the data as a data set into the Python environments. For that aim, we use mostly two libraries. And you already, I don't know if you have started working with assignment number 1. So if you haven't, don't worry. Today I'm going to show you. You're going to get there. I'm going to show you what you need to do, and technically what we have in the book, page 61, is pretty similar to what we need to do for the assignment number 1. And the good thing is, you can read until next week those few pages, 2 or 3 pages, and you can do the assignment, and still we have time. Guys, I don't think it needs something more than 2 or 3 hours to finish. And already lots of people have finished. But one of the things that we have here is vectorizing. And what is vectorizing? It says that most people that they come from other languages, they do not use this specific feature that we have here, which is called vectorizing. That nuts and bolts expression, I like it. It says everything that we have done as basic foundations of, we're going to use them pretty soon. And it says when we use that mindset, not using U functions, and use the thing that you normally develop in languages like Java and C#. You see, the performance is very dismal. It's very low in performance when you use Python. All of you can explain this code to me. I want you to spend a few seconds with your team members and tell me what is happening in this code. Just within a group of 2 or 3. Yes. Don't worry.
Basically, it's gonna first get random numbers, which is random.c, and then we're gonna create a function.
And how about this? Let's start, if you don't mind, from the function compute reciprocal, and then we're going to get to that.
Basically, in the function, there's an empty output, and the length is values, and then for every number, it's going to be I. The output is going to be the value 1.055 values in the length. The output is going to be the numbers between 0 and 1, and the size of the array is going to be 5, and then
Awesome. So that's the functionality of the function. But let's just now bring it to one example. Imagine that we have an array of 5 elements. And that array of 5 elements is now the values. So please recompile it, knowing that. So tell me what's happening in this line. Imagine that now values is an array of 5 elements. Do you want to step in instead of?
Yeah, the values are reciprocal.
So we get those values here as a parameter, and what are we gonna do next? In next step, Stefan, do you want to step in? Not. What's your name? By the way.
Me.
Meha. So for the next guys, let's do it this way. So each line 1%. What is happening in the next line? Yes, sir. Lovely. Making an array of the same, yeah, length. What's your name, sir? Number 5. Numbers are sentenced to change next week, but thank you. Casey, yes, we are going to make an empty array with the same dimension. Empty array means that it is filled with 0 or what? It fills with 0. Yes? Yes? Who says no? What was your name? Yes. The other section who came this section. Mega. I remember making. I remember Shada. I remember NS. I remember who else? Everybody's gonna say now. And Matthew. Okay, exactly. When we say empty means leave it as it is, whatever is there in the location. We don't, because we are gonna change the value. So why should we bother having one extra step to put 0 in those locations? Let's leave it. We are gonna update it later, right? And the next line, we are going to use I as the index of every single element. Why it says that length of values? Imagine that we have 5 elements. Why it says in the range of 5 more? What do you mean? First, we have 5 elements. The range should be. The range should be 5, or what is the first index? 0. What is the last index? So, right? There's gonna be 0, 1, 2, 3, 4, but not 5. And whenever we say range, yes, I gave you. No. It means that. And then we say that for every element in the original array, calculate the reciprocal. Does it make sense? And then place it inside where? The output array that already has some garbage information from previous. Then we're gonna update it. If I see somebody writes their code like that, I definitely say that person has come from Java, C#, C background. This totally makes sense in all those languages, but not Python. Let me just give you one example. Imagine that, remember, the seed was 0. If I said, let's have a number, random integer numbers between 1 to 10, and what is the size of the array? 5. And then calculate the reciprocal. To understand it better, I just split it into more steps. If you say what are the values, guys, do you like to try it at the same time? And if you don't get the same result, please just say random.c 0, then you should have the same result. Whenever you are done, give me a signal, then I'm gonna explain. Thank you. What's your name, sir? Carl, number 4 it should be. Carl, right. Where's your name? What's your name? You're not. Okay. Dolan. Donald. Bonus mark, man.
But please help me now. My brain doesn't work properly. Don't know. It looks like French. Yeah, it is French. Huh. Nice. Okay. So. That is fine. That is fine, when we are dealing with something like 5 numbers. But what if we want to generate random numbers between 1 to 100, is not including 100? And how many numbers? 1 million. Then just use timing. Guys, it's crazy, it's just 5 seconds for something small like that. And I want you to think where the bottleneck is. You have the code, think, talk to your friend, say where the bottleneck is. Another bonus mark is waiting for you. So just find the error. I don't need any solution. I just want to see the error. Because we are engineers. If we know where the error is, we are gonna fix it.
Sorry, those who didn't get any bonus, pardon me. Is it because you're declaring an empty array?
Is this because we declare an array? Right? Means that this, let's just say, line 1, 2, 3, 4, 5. You're addressing line number 2. Yeah, Harlan? Every session I give 1 bonus mark to wrong answers.
Oh, okay, yeah.
Good. Thanks for participating. And there you go. And this, let's just give a few seconds to those who do not have bonus marks yet. Okay, so you first and that's you're gonna say it again. Okay, so please. Don't worry. For loop. This is exactly what I was expecting to hear. There you go. But it's not good. But because it is close to the bottleneck, I give you bonus round. Who else? Hey. We know that line one is not correct. I mean, he asked me to say line 1 is not correct. Line 3 is already taken and we said it's not correct. Line 3, 4 is not correct. So we don't have that much, I mean, lines. The last one return is not correct as well. So which one is the one which is bottleneck?
Well, when we for loop itself, that's running properly, so.
We just even talk about one line.
Yeah, or the, in the one line in the fourth, the bottom.
That's right.
People are gonna get suspicious. Why do you think that much? Okay, look, Enes, do you want to add anything? Look at this one. Here, if we say 1,
I can just scroll it down, right? Not to.
what is this? It's 1 point, yes, wait, so, sorry?
Oh, you're so redundant.
Redundant, true, but, well, at the end, we cannot say because we have 1 million number, just calculate one of them or 100 of them and forget about the rest. We have to calculate, so it's a kind of redundant process. But what is the redundancy? What is the part that we can just? Yes. Sorry?
Actually, you answered the advanced part of it, which is not part of this question, but you get one bonus mark because of that part. But listen,
Yes,
Lucas. You want to
The
say?
answer you're looking for the fact that it's flow, divided by nature.
Pretty close. So Lucas with K.
good. Listen to me. We have division here, right? For the sake of that division, you have to check every single element in the loop if the type is fine or not, because
Tell me, guys, I know that it is simple, everybody knows the answer, but what is the functionality of this? What is the functionality of this? For us, hey, come on, everybody knows addition. But for computer means that, oh, first let me check. If two strings, then the meaning of this one is concatenation. If two integers, it's like summation of two integer numbers. If two floats, summation of two floats, and if one of them is float, the other one is integer, I have to typecast and it means what? Means for every single element of that 1 million record, I have to do the type checking. And it is very much almost. Is there any way that I can say, okay, all of these guys are the same type and don't do the type checking, and just do it? You have one bonus, yes?
Just by using a type bar.
By using
By using a type array and
typed array. I like that. Yes. Kind of, you're gonna use that. Your name, sir? I know. Raleigh, 38. You are.
Look. You want to add anything?
Do you add an argument in the empty method to be like a comma after blank values here?
Yes, I do love to listen to all of your comments, but if you don't mind, just to the interest of time, sorry, I forget here. Let's, go a little bit further. It is partially correct what you said, but look at this one, guys. How about this? Whatever you define as an array and you call, it has a loop built in, so we don't need to say go to every single. I repeat it. In NumPy, whenever you call an array, it means that array every single element of it. So typically, as simple as that, instead of calling a function like that, what if you say y1 divided by values? It's going to give you exactly the same response. By saying that, you don't get rid of that. You don't get rid of that loop. Actually, technically we do, but you get rid of that type checking that we have in line number 4, because all of them are the same type. This is the facility that we have in arrays. Whenever we have arrays, we don't need to do the type checking. Yes, Matthew? Actually, we add one more step. At the end, look at this one. At the end, you're going to replace whatever we have in output array, which we define as empty. You're going to replace it with reciprocals, 1 divided by. So you just add one more step. saying that, okay, you make a frame, then put zeros and then replace, you don't need that, right? Okay, but good point. Look at this one. If you say, let's just check the time it. If you say here, using the function or 1 divided by values, the results are exact identical. And now it's the time to see what if we use that big array, say 1 divided by big array, instead of 5 seconds, can you see 2 milliseconds? If it was 5, it means that it's like 1,000 times faster. And it is like 2,000 times faster, even more than 2,000 times faster. 2,400. Please try this and see if you like. Done. If anybody wants to copy the code from the book and not to type it, we are in page 51 based on the PDF. So look at this one. It says that it turns out that the bottleneck here is not the operations themselves, but the type checking of that, right, Shreya? But the type checking and function dispatches that CPython must do at each cycle of the loop that type checking. Every single iteration that we go through, we have to do that type checking. And please read that, and it says, hey, this is something that makes Python slow, so we introduce U functions. And one of the people said, Reza, why U functions? Well, they should put a name for it, so they said universal function, right? And they use vectorized, so that for many types of operations, NumPy provides a convenient interface into this kind of statistically typed compiled. The thing is, in that case, we said, hey, you know what, you don't need to compile it to an array that you have in C or C++. Use compiled format, don't use what the Python interpreter format. We call it vectorized. And it says that this vectorized approach is designed to push the loop into the compiled layer that underlies NumPy, which is nothing but C or C++, leading to much faster execution. We already checked that. And okay, this is the, how about these two? It says that those U functions are not just for using one scalar and one array. We can just use for 2 arrays, as you see here, for instance, NumPy array range 5 and 1 to 6. What is the output of this? 0 to 4. 0 to 4. Lovely. And how about this one? It's 1 to 5. So the first element of this 0 divided by 1, correct. The second one is 1 divided by 2, right? And then 2 divided by 3, and so on and so forth. This one, 3 divided by 4, and that is 1.
Not that bad, right?
Also, imagine that you have, maybe your question was, for instance, we have 9, right? How many elements do we have? What are the options that you have to reshape it? 1, 9, 9, 1, or 3 by 3. Right? So what if I say, let's just have 2 to the power of x, what's gonna be the output?
Every bit is gonna be,
Okay, guys, how about this? I'm gonna just hide this part. Do it. At your convenience.
Then just explaining to your neighbor.
What is happening here? Because I see that people are just
Yes,
I'm trying to understand, is you saying that makes legalization of the first form of method was 2 times, so we didn't have to check. Or
exactly for every single.
Okay, and you say that there's built-in universal functions that allows just to work with the array by itself, and it understands the array by default.
And it's not gonna do the type check,
Okay,
right?
so
It knows that, sorry,
so we know that ahead of time, correct? But if there are some issues, then
the thing is, people getting to that state, to that state. Actually, for instance, you wanna place render while the array of integers, generate errors, so we are not gonna get there, to have. Like inconsistency in the data that we have.
so it's really consider the data, this is better.
We don't have any other option. We only have consistent data. Otherwise, if you want to place, for instance, something which is not fit, if there's a capability, let me just tell you one example. Imagine that your array is initially was 1, 2, and 3. And you say that, and let's say it's x, and you say that x is 0, right? I want to replace this one with 3.15. It's going to say, hey, you know what? I can't accept the decimal points. I'm going to convert it to. And if you say that, you know what? I want to place A, B, C there. Can I say that's impossible, error, because there's no possibility for it. Does that make sense?
Yeah.
done.
I like to just numbers like arrays.
Array, okay, array range. No. If you want, you have to say dot sort. You can have random numbers. We had some examples that we created random numbers, so it's not sorted by default. Okay, the question was asked that how about a range? Is it going to? Oh, you're saying that array range this one, not array.
Yeah.
Okay, it's going to have a start and so technically it is. And it is possible to have, for instance, say that every other element. You're gonna have that example today. No time. Sorry, I didn't get the question correctly. So let's go to the next part. It says that anytime you see such a loop in a Python script, you would consider whether it can be replaced with a vectorized expression. In other words, hey, whenever you have for loop, think, is there any Python way to eliminate the loop? Yes or no? I repeat the sentence. If you have a chance to use any other approach rather than using loops, do that. Don't use loops as much as you can. Because whenever you have loop means that do the type checking every time. Huh? Exactly, that is one issue, but the issue here is more complex than time complexity. Big O is in some languages like C, C#, Java. But here, apart from that, we have another complexity, which is checking the types in every iteration.
So now let's go to this one, which is exploring NumPy's U functions. But we have two types of universal functions. One of them is unary and the other one is binary. And we are going to have some examples. And I saw that some people, guys, this is the reason that I say the best is to practice. I saw many people, they had some issues in using some unary functions. And let's have 10 minutes break. And after that, we are going to just work on it together. Okay. Thank you. Oh, my gosh. What a day. یعنی هرچی من سخت‌تر میگیرم دنیا سخت‌تر میگیرم امروز دیگه صدام نمیاد خود یک صدا مظلوم‌تر میگه گوشم سرخه جام نه عصبی میشم مثل تمام ایرانی‌ها آمون
Hi, man. I hope you're doing great. That's awesome. I'm in a class somewhere else, so I'm gonna check it later, and I'm gonna consider everybody marks for that. Thank you sincerely, and keep doing what you're doing. Awesome. Could you find the videos? Could you find the videos?
Oh, yes. And you also pick
Really?
like 1 hour. Still.
Sorry about that, because when I get prepared for the class, I didn't check my emails. I'm rush to make everything. Okay, awesome.
Yeah.
Good job. You're from Quebec? Rudy, and the language there is French?
No, it's true. But I'm big fan to get along with schools and something like.
Oh, nice. Great. Then I can learn it from you.
I will try.
Okay, we're gonna start in a few seconds. یعنی وقتی خونه تکونی میخوای بکنی بدترین کار اینه که وسطش بشینی یه چای بخوری دیگه دلت نمیخواد است. بهترین کار دیگه دلت نمیخواد است. مگه کدوم سمت هستی؟ شوخی میکنی؟ دقیقا رو برو شده همسایه یکی رو پیدا کردیم باش بریم تنیس بازی کنیم تنیس بلدی نباشی هم یادت میاد. Okay. So little by little, let's just continue. If you see that we have U functions, and U functions have two types, universal functions. One of them is called unary, and the other one is called binary. So what type? Well, for instance, an example for unary, like -5, right? If you say -5, it's just simple unary universal function. Everybody, can you please try these samples, and let me just bring it to you here. There we go. So let's say a range 4, which is going to be 0, 1, 2, 3, for sure not 4. Oh, by the way, what is the name of that thingy at class? I always forget, don't worry. And people say, why the participation in your class is so low? I was like, that's me, I forget to tell. H7W8, if it works. H7W8 works?
Yeah.
Yay, okay, so let's continue. Look at this one. We say plus, you have all the right to say, Reza, what is the function here? There is no function. We just have plus, we just have minus, we have, what do we call it, multiplication and division. And what is that? Is it remainder or what? Remainder, is it? Don't read the Sorry? I heard something, but I don't know who is the source. So what is it, Shayda? It's going to be integer, but what type of integer? It's going to be round up?
No, it's gonna be.
Shayda, one hint. Most of the time, 99% when I say something, it's opposite. Okay? Just some Maharshi. Maharshi, where are you? Found it, number 25. Yeah. Okay. It's based on first name. Yeah. So how about this? If we say negative, guys, the question that I asked you, there is no function. So why I said universal functions, U funcs? Anybody can explain that? Yes, Matthew. So where is the function? That's my question. We do it over the array. Fine, but I don't see any function. You see, it's just plus. The question is, I think that, correct me if I'm saying nonsense, the book talks about universal functions, but the first example is anything but function. It's just plus, minus, these kind of things. Functionality of the NumPy array.
Good guess. I'm very hard to be convinced. So another try, anybody else, but thank you very much, Matthew. Anyone else? Yes,
Basically, it's like, you know, like it's basic mathematics. When we have this like plus sign, it's gonna like add two things together based on the like the type of the value that you're giving. So it's kind of like with like function that all like the function that is non-part.
I liked it. Thank you very much. So let's see, Matthew said everything in Python in NumPy is actually kind of array, right? Am I right? Matthew? You said everything in NumPy is a kind of array.
No. We differentiating the NumPy array, like the NumPy array is a class, therefore everything has access to those sorts of functions. So when you are functionally doing something.
So we haven't started any function yet. You mean that, right? We just started using NumPy arrays and we say that, okay, later we are going to use functions. Okay. What Maher said is actually when we use plus, it's not operator. It is a kind of mask. It's an overlay on top of functions, a function like numpy.add, which is correct. So whenever we say plus, whenever we say minus, whenever we say any of those, look at this one. We technically use this. So plus just represents numpy add. This one, negative, could be the representation of numpy.subtract, or if we have just one number, it could be negative, for instance, -5, -2, negative something, right? Yes.
So it's basically a class function that's overriding that after you NumPy.
It's exactly there. If you are dealing with arrays, it knows that, hey, we need to use NumPy version of plus, right? Good. And look at what it says. It says that, hey, whatever we have, all those arithmetic operations are simply convenient wrappers around the specific functions built into NumPy. So it's not plus, it's actually at, and so on. And look at this one. Here we have negative function. Here we have power. And here we have the remainder of the division, right? So module 2. Yeah, it talks about all of them. And then let me just go to the NumPy version of it. How about this one? It says that in the next example that you have in next page, it says it's not always simple. It could be kind of something complicated like this. But I thought that not a bad idea, just to see what happens in every step. And I simplified it. So it's like first multiply 0.5 into x, then just add 1 into it, and then to the power of 2, and then negate it, right, by saying -1, and that's the result. So would you please spend 30 seconds or something, try all these 4 lines and explain it to your neighbors after that? Yes. Making
Mahshot, Mahshot. Enes is there. Enes neighbor, what's your name, sir? Kirus. Thank you. Your name, yes. John Seltzer, awesome. What's your Ryan? Khadija? No, I just want to double check that you are Khadija. And Khadija's neighbor is, what's your? I think And you know what? You're ready. You're ready. One after me. Okay, so in the next round. In the next round, I'm gonna just take care of the attendance of the other side, but everything is clear. Guys, the speed of the class is moderate or what? You can follow? Okay, awesome. So I had those profs that they just talk on this, and they want to the just word, not checking that if people can follow or not. Talk for 1 hour, so please. I think that I'm getting to that age, right? So I think that pretty soon I'm gonna be like one of them. So start talking non-stop, but not checking the audience. Okay, guys, can I have your attention, please? This one is exactly like say plus 2. So before trying this, say x plus 2 and see the result, would you? X plus 2. What's happened?
MATLAB? It's like having an array of all those values, right? Look at this one. What is the original X? Tell me.
0, 1, 2,
0, 1, 2, and 3. And if you say that plus 2, what do you think? It's gonna just add these two to the first one or to the last one, or
From
okay? It's like
3.
making this one like the same size of the original and add 2 to every single one of them, right? It's like broadcasting. Be prepared. Next week, we're gonna talk about this. The whole session is about broadcasting. And we are gonna use this broadcasting in deep learning a lot. A lot. Let me ask you one thing. Imagine that you have 1, 2, 3, 4. And you say plus 0, 1. What's gonna be the output?
1,
1, 2,
4,
4, 5.
It's gonna be 1, 2, 4. Are you sure it's gonna be 5 or 4? Because we just, excellent. It's like broadcasting the same size, right? But now the question that I want you to think about, and I have no answer for it, at least at the moment I don't know anything. If you have 1, 2, 3, 4, let's say 5, 6, something like that. And we say plus 1, 2, 3, 4. What is the output of?
1,
2,
so 2,
4,
4, 7, 6, 8, and
6, 8, 10.
9.
Did I already give bonus mark to wrong answer in this class? Okay, sorry, but Marshy. Thanks for participation, Marshy. But guys, a simple way is say this one is X, this one is Y, and add them together, see if it works. Yes, sir.
I'll give it a shot. 2, 4, 5, 6, 8, 6. You're only going off of indexes of each array.
Oh, don't tell me. I didn't have time to check this. Try it yourself. X plus Y. And give me this. Yes.
What about 1, 1, 2, 2, 5, 3, 3, 4, 5?
And again, the easiest way is X plus Y. Do it on your computer. Yes.
Is it an error?
Error? Lovely. Okay, now that we got error, guys, successfully we got error. I want you to think about the reason of that error and bring it next week. Why it gives, guys, I don't want to tease you. The reason that I'm telling you this, because if you think about that problem, why we get error in such cases, our brain is ready to understand the logic behind broadcast. And when I tell you, you're gonna get it like this. Okay? Thank you very much. Okay, everybody. Tell me. It is binary. It is binary. U function, true, false. As simple as that, guys. Look, too late. Lucas. This is NumPy version and this is Python version, true, false?
Could you repeat?
This is NumPy for sure. Guys, when I ask you, one of the ways to give the correct answer is just read the green line. What's it? This is alias for the same thing. Why do you have all those? Because somebody defined this in NumPy and you have something similar to that in pandas, and we want to, sorry, in Python, and we want to, just have similar functions. Does it make sense? Look at this one. I have forgotten what this guy is. Anybody has any idea? Do we have any mathematician in the class? Okay, what do we call this guy?
In the matrix. So first array will be 3 and the second one will be
Is for, let's see, if I knew that, I didn't ask, so, yeah.
Yeah, basically 3 minus 4j means 4 to get by j, so 4 of the j.
Lucas,
These vectors.
vectors. All that is saying that, hey, come on, something is, yeah, anybody remembers anything?
Like, the total,
Row and column, guys, it is not that complex. Right? It's not that complex. Yes,
Are you asking if it's a polynomial?
guys, it is not complex.
Each time you do it.
It is complex numbers. Right? Imaginary parts and real parts. Right? But the main question is then what is this? You talk to your neighbors and tell what is happening here. Why? When I say absolute of this, it's going to give me 5, please. No, ma senza guidare. نوش جان خوردم. شیر دارم. میتونه یه چیزی میگیره که من نتونم بکنم. No, but so yes.
You get the array j with j and it will be 3 minus 4 times that is the 8. So 3 minus 8 will be a negative 5 and the absolute value of that will be 5.
Okay. Who else? I didn't, guys, I need at least 2 explanation to understand. So who's gonna be the next? Khadija, you can try. You can ask the other person. Ask it to the next. Yes. It adds 2 to every single element. So it was 1, 2, 3, 4. So it adds, sorry, it was 3, right? It was 0, 1, 2, 3. So adds 3 to every single element. Then it will by itself. It's gonna add 0, 0, 1 to 1. When the dimension needs no broadcasting, it's gonna use normal, right? Okay, guys, it's simple. It is like 3 to the power of 2, 9, plus 4 to the power of 2, 16, 16 plus 9, 25. Then the square root of it, it's gonna just give 5. The same for this, same for this, and the same for the last one, right? That's how we calculate absolute in complex numbers. How about the next one? That's how we say it's 2 dimensions. That's how I desperately pass my engineering math, and it is all engineering math. I remember that. When I was a student, everybody said that, Reza,
math engineering, your goose is cooked. Don't take it. You drop it once, and then you can pass it second time. I was like, okay, I don't have money to pay for 2 semesters for that. So what I did, I just went to the prof and said, is it possible that I participate in 2 different sections? Said, okay. In one of them, I took note. We don't have any recorder back then. And then so I took note in one, and in the second one, I started learning. So I passed it with mercy, with something like C, not with, yeah. Anyway. How about this one? First thing first, 0 numpy.i, comma 3. What is happening there? What is late? Well, actually, it's line space. When we say line space, what does it do? I find that. What does yes. I can answer that. You can have lots of bonus marks and give the chance to people like President. Anybody? Somebody? Yes.
Calculated with space. And it's space the power 3, maybe. You get 5, 3.14. Familiar with space.
Awesome. Again, if you want to, yes.
So our line space gonna given this space equal to pi value, which is 3.14 to 3 powers.
Okay. As Marsh said, imagine that we have here 0, and what is the second one? Pi, which is 3.1415 something 49, which is pretty close. You see here 159, 14159, and so on and so forth. And we divide it into 3 portions. One is going to be 0, the other one is going to be the half of it, and then finally pi. So we have those parts in theta. The sign of 0 is what? The sign of 0 is obvious, but the sign of 0 is 1. The question is, what is 10?
Sign of 1 cos. So 0.10.
But the problem is the tan of this one is going to be the same, right? Why? We have 1 here, guys. You remember this circle that we had in trigonometry. So the degree of that, when it is 0, we say that the sine is 0. The sine of 90 degree is what? 1. And the sine of pi is, sorry, the sine of this one is going to be 0 as well. But instead of showing 0, it shows 1 point something, 1.
Because the value is 3.5 will not
It's between.
Again, I'm asking, let's see, what's your name? UI, right? It should be 0, 1, and 0. You remember the circle that we have like this? The sign is going to be 0, 1, 0. Why is 0, 1, and again 1? Yes, look at
Not using pi to all, that's the value of that. If that value to the negative 16, it's a very small value.
that's what I was expecting to hear. Look, Lucas said, hey, Reza, it's not exactly 0, 0, but it is to the power of negative 16 is very small number. Right? And because it's not, nobody knows the exact number for pi, right? And the precision that we have is acceptable, right? And that is why the ton of this number should be infinity. Right? Because it is sine over the sine of that. And it's going to be very big number, not infinity. Because this is not exact 0. Huh? I just want to tell you, what you see here is not what you get in math.
because we have problem in procedure. Right? Look, what is tan? Tan of x. So in the second row, the sign of this is going to be 1 divided by 0,
which is infinity. But we don't have that.
because it is not pure 0. It's a very small number. So if you divide 1 over 1, very tiny number, it's going to be a huge number, which is this one. Yeah, accept it as infinity. Does that make sense? Guys, I just want to tell you that what you see here is not exactly what you saw in trigonometric books. And the reason for that is not having precision. Okay, so I don't know this part. In a group of 2, 3, please explain all these things to your neighbors and somebody who feels comfortable. Share your knowledge about this part, please. Neighbor.
Yeah.
Help neighbor. Don, Donald, Dolan. Not Donald. I know that you don't like him. Dolan. Dolan, right? Down to Dolan.
No. Like that.
Don't worry, you're going to exactly talk about that because that's what people are afraid of, right? Yes.
In short, basically, it's doing the reverse of sine, cosine, and
Merci, Enos. Okay. Can I have your attention, please? The question for, you remember that we had for sine, we had 1 here, positive 1 here, negative 1 here, right? Something like this. So we had 0 for here, 0 for here as well. If you look at this, we ask for which angle of the sine gives us -1. Tell me, for which angle? Negative pi divided by 2, right? If we go this side, negative pi divided by 2. And that is why if you check the number, it's going to be negative 1.57. Everybody? Khadija, everything is fine? We said that, hey, if you go counterclockwise, it's going to give you positive. If you go counterclockwise, it's going to give you a -1, right? John? Shada? Everybody? Okay. How about the next one? 0. What is the value for 0? Obvious. In 0 and pi, but we never say pi again, right? We start with the smallest. And how about this one? Positive 1. So go counterclockwise, right? And it's gonna be this pi divided by 2, huh? Okie doke. And now it's the time to answer one question.
that Stefan asked. And that question is, I'm gonna tell the scary part and have you to be. You have to know every single things in math that we taught. But do you think that this is a math class? Okay, come on. The problem is, and that is something that I heard from many. I had a student here, exactly, and she got full-time job. I don't know, in BMO or CIBC, one of those big names. After 2 weeks after graduation, just 2 weeks after graduation. And I remember the time that she called me and said, Reza, I have a stress. For what? You just graduated. What if I cannot find job? Like, hey, you are A+ person. If there is one person who should find job, this you. And she asked me exactly the same question as Stefan. So Stefan, you can just say that you can get your full-time job after 2 weeks graduation. She exactly asked that, said, Reza, I wanted to work in the field of data science, but my brother told me that you are not for that. Like, why he said this? Because your math is not great. I was like, hey, come on, my math is not great too. And I'm new. The problem is people think that if you get hired in, for instance, Amazon or Google or RBC or CIBC, every day they say, okay, this line, your task is working with complex numbers. This line, you should just go and open your book, trigonometry, start calculating. Come on, it's not like that. In some places, you need to just do some simple calculations. And the good thing is, for many of the cases, already the will is invented. You just need to find a function. And even you don't need to know what that function does. Just use it. As simple as. Okay? And now, why emphasize on one question? Because that's the beginning of next chapter. Next chapter talks about exponents and logarithms. How many of you remember logarithms? Good for it. Wow. Seriously, I don't remember. How good. What a class. Anybody can tell me how? Okay, guys, we have another prof. The problem is if I start showing you that prof, you're not gonna listen to my lecture anymore. Come on, because she explains well.
Hi, guys. I'm Nancy, and I'm going to show you logarithms. Logarithms have a lot of potentials, so I'm just going to call them logs. And here are the times I'm going to show you. So if you see something up here that looks like the kind we're trying to figure out, you can use the links in the video or the description to skip ahead. So I'm going to show you first the basic kind of logs. I'll show you some weird kinds. We have a lot of negative number, zero, point, or fraction. I remember hating fraction thing. And I'll show you natural logs, which are a special kind of log. And finally, some even weirder logs, and by that I mean if you have an x in the log part of the expression, or if you have to use the chain of base form. So let me show you the basic ones. Okay, what if you have a basic log expression like this?
Hey guys, does this place sound familiar? You go to a confusing lecture, you ask for help, but your teacher can't explain it.
What is that? How do you even read that expression? The way you read it is log base 3 of 9. But how do you evaluate it? And what do you have to say?
Okay, what I learned from her is we have to say 3 to the power of which number gives us 9. Does that make sense? What is the number? Up, right?
Well, by how do you do it? There are a few ways. One way, if you're the kind of person who likes to do things in your head, you can just think to yourself, 3 raised to what power gives me 9. And if you can do it that way, more power to you, you're cooler than the rest of us. But for all the rest of us, usually the easiest way, the fastest way, is to rewrite this into exponential form. And I will show you how to do that. But the first thing you should do is, if this doesn't already equal something, make it equal to x. And there's a reason for that, because you're going to rearrange this and connect it to an exponential version. How do you do that? There's a pattern we can use. And here's the pattern. To rewrite this in exponential form so that you can find the answer, you start with this little base that we circle. This is the base of your log expression. Start there and move in this direction of the arrow. And raise that base to the power of what's on the right side. So the base 3 raised to the power of the right side, which is x,
All of them.
equals, set it equals 9, the middle number or the other number that's left, power of this. All right, so I just rearranged this into exponential form with that pattern.
Okay, guys, look, any topic. And if you think that people who are into programming, data science, or they know everything about math, hey, if they knew everything about math, they shouldn't end up being programmers. We just use these things as like the tools that we need to solve the problems, right? Look at the next. I have already shared all these things. So you see Wiki for logarithms and so on. So one of the things that we use is the Neperian or natural number. If you say EXP, look, 1, 2, 3. It's Neperian or natural number, and the Neperian number is 2.71 something something. It is something strange like 5. 2 to the power of, 2.71 to the power of 2, it's going to be something like this, and so on and so forth. How about EXP2? Can anybody tell? Guess. It's to the power of 2? No, it is 2 to the power of x, right? It's, yeah. So it's gonna be 2 to the power of 1 to the power of 2 to the power of 3. But I don't very much like this one because I always mix it with Neperian, natural. So I use this. Okay? 2 to the power of x, 3 to the power of x, and so on. Do you see that? The essence of universal functions can be found in anywhere inside NumPy. Whenever you say x, it doesn't mean just one number, it means that an array of numbers. So 3 to the power of first element of the array, and second, and so on and so forth. Everything is fine. So how about this one? Now, please explain this to your neighbor. What is the log of, and I received one very good question in the previous session, and I gave bonus one because of that question. So check everything you can guess. The log 2 means that the base is 2. Log 10 means the base is 10. So 10 to the power of which number gives you 1? Can you tell me? 10 to the power of which number gives you 0, right? Okay. 10 to the power of which number gives you 10? So that is why you see, but I don't know about the rest, so please talk to your neighbor. Do it, finish it. So the next,
Audrey, is there? Audrey? Good. No, I feel just. Thank you. And Mr. Wright, what's your first name? Smiley. Can you just please say first name alphabetic and then your what's the first name? Okay, what is her name? Michelle. I'm sorry. What is it not to be? Second. And we need to go L E and Donald. O. After I finish the next support me after, I share it. At the moment, like there's people just wanted to become items. I all had the point that I thought that maybe that we feel like that's why I always sure. Your name? About what? I know. And your name? Nigga. I know, nigga.
Yeah. You'll get
Okay, and first letter of the name. Hurrah. So, yes, awesome. And what's your name? You know, your employee from the board. But what's your name? And what's the same? You are? Yes.
Yeah.
And sir. What's the first letter of your name? C. Tiger. Excellent. And what's the first letter of your name? Okay. Page one. Now we have Wanda. We have Rolling. We have Casey, we have Richard. We have don't say. Yes. Sorry. What is the first name, please? And no. Awesome. And what's the problem? E. It's Eva. Here, so we have nerd, and we have Matthew, and we have another thing. We have Lucas and Sarah. H U Y point. Oh, I made a mistake then. Yana is, I just gave Yana. So let's quickly go through the names. Abhishek is not here. How about Art? How about James? Orla? The other Lucas? No, the other Lucas. Lucas we see. Muhammad Ali was here. Amar, Pawan Kumar, Peter is not here. Sabrani. Okay, so how about this? Can I have your attention, please? So, did you talk to your neighbors about these guys? So technically, when you say log, it's based on natural number. So 2.771 to the power of 1 is going to give you as, where is the, yeah. So what number should we say Neperian number or natural number is going to be to that power, and it's going to give us 1. So it's going to be 0, as you said. How about which number we have, and we say to the power of that number, and it's going to give us 2. It shouldn't be 1. It should be less than 1, because if it was 1, it should be 2.7, right? So that makes sense. We can understand what is happening here. The same for log. This is 2 to the power of which number gives us 2, 1, right? And that is why we have all those numbers. Anyway, this part is, Stefan, this part is scary. Only math and pure math. Let's just see. First thing first, if the number is very much small, are we going to use the same exponentiation? And what do we call the other one? Logarithms, the same way? The answer is no. Almost 3 years ago, they doubled the precision. So if you check the answer in book, it's different from our answer. I want you please use x equal to these numbers, and then calculate exp m1 and calculate exp normal without m1, without considering small numbers, and see if the answers are equal or not. Whenever you are done, please give me a signal. Done.
Okay. So. Um. Done, yes.
So one of them is just giving explanation and other one giving explanation minus one.
Well, the thing is, it says whenever the numbers are very much small, that is the page that we are covering at the moment. It says that specialized functions, and what are they? One of the things that we are gonna use, oh, sorry, before specialized functions. It says that when the numbers are very much small, like here, we use some specialized version that like AXP-M1. Previously, the precision that we got with AXP was different from AXP-M1. Right now, if anybody asks you, you could say, these two guys are gonna give you the same precisions if you need something like 6 digits after decimal point. But more than that, they are different. Did I say it the way that we can grab it? Look, if the precision that you need is just 2, 4, 5, or maximum 6 digits after decimal points, both of them are similar. They work the same. But if you need more precisions compared to these, then you need to use what? You need to use AXP-M1 instead of using AXP. My suggestion for now, and you can find in one of the 3 first Stack Overflow, just in a sec, Stack Overflow examples, search when to use AXP-M1 and see if you get the result. Enes?
So if you say that XP, X is equal to XP-M1 X plus 1.
The thing that makes these two guys different, it's not because of that, it's because of the precisions. You're right, but the main reason is the precision. Yep. Let's just, if you search this, and let's say Stack Overflow. I checked it last night again, so this is not the best, but there's another one. And the answer mentioned it specifically that after 6 digits it shows. Anyway, just try it. Is it here? Short answer. If 6, here it is. If 6 significant decimal digits are enough for you, this guy is okay. Otherwise, you need to use AXP-M1, right? And I remember at the time that I tested, it's already, 3 years ago, 3-4 years ago, they already converted the number of precisions. So you can't see the difference between these two. Now let me show you my version. So if you see, there is no difference between these two calculations because the number of precisions are less than 6 digits. They are almost identical, yes?
When would you need to have more precision than the 6?
In this scenario, I'm not a mathematician, but maybe somebody says that, hey, I need to calculate 12 digits, then I have to search and I know that there's a backdoor for it, right? I can use that. Again, I'm gonna bring you to one, I have no clue about the math part. I just use, good question anyway. So the same thing for log 1p. And for that one, look at the same result that we have, if you use log y, guys, I was lazy. I said instead of saying 0 and then 0.001, I just said let's add 1 into every element. And I calculated log and log 1p, means log plus 1. Huh? And the results are exactly identical. They are exactly identical because I'm saying after the date of publishing this book, they changed the number of precisions. But right now, I want to ask you to read about gamma. What is gamma function? Anybody has any idea? Gamma function. And to give you enough stress, you have 30 seconds to find out what is gamma. Yes, sir.
Except negative and zero, it's correlated with minus.
At least the gamma that I know is not that. Maybe I'm mistaken. Okay, how about this, guys? To the interest of time, let's go and enjoy. How many seconds do we have here? 41. Let's see in 41 seconds, can we understand what is gamma?
The gamma function is one of the most advanced functions in all of mathematics.
You guys, somebody who has heart problem, if just they look at this one, they're gonna have heart attack. But the good thing
You can
is,
see here that gamma as a function of x is defined as the integral from 0 to infinity of t to the x minus 1 multiplied by e to the minus t dt. And it was in 1730 that the mathematician Leonhard Euler wrote in a letter to the German mathematician Christian Goldbach that the gamma function is equal to the factorial function.
done, guys. As computer engineers, we are done with this. We got it. So gamma function is going to, if you get, for instance, 5, it's going to calculate what? 4 factorial. Done. You don't need to go and create this kind of things. Listen, if I say here, import SciPy, scientific Python library, and import the special functions, and if I say, calculate for me gamma x, what is the factorial 1? Oh, sorry, what is the factorial 0? As a kind of convention, we say factorial 0 is 1. That's convention. I know that it's not 0 times anything. What is the factorial of 5? Sorry, 5 minus 1. What is the factorial of 4? I am lazy, just 24, right? So, and look at here, it says that 2.4 multiply 10 to the power of 1. You see the result? And what is the factorial of that? Oh, that is serious. So just calculate it later. That's going to be factorial 9. Huh? And that is the 10 to the power of 5. Okay. How about this one? Now we have Earth. What is Earth? Oh, yeah, it is mentioned in front of it, error function. But error function for what? Okay, Stefan, do you think that I need to know what is integral of Gaussian? The answer is very simple. Who cares? As long as it works and the client is happy with the answer, it's fine. And if you see that I am this relaxed now, still I'm not very much relaxed person, but in general, I'm talking about these kind of things. Because I had that tendency that I need to know what is happening and what is the root of that. Right now, I just care about if the answer is aligned with what client wants. Finish. What about this one? Everybody, this is page numbers 56. I want you please, guys, I can just answer it in 5 seconds, but I want you please to spend a few minutes, talk to your neighbor and say what is happening in here. And here you have the answers to, let me just bring it. Okay, anyone can explain, please? Yes. Awesome. So it's gonna be a range between 0 all the way to 5, but not 5. So it's gonna be 0, 1, 2, 3, 4. What else? Okay. Yeah. The next part is why says it is 0, 0.30, and so on. What's the meaning of this line? Is it divided by 4 or something? Any opinion, any idea? Don't worry. Yes.
If it's empty, they're just placeholder.
Good start, man. Today, Stefan. Bonus. Look, as Stefan said, hey guys, whenever we have, I'm not going to give you a bonus to anyone else. Yeah. Whenever we say empty, it means that whatever we have already in that location of memory, just keep it. Don't change it. So there should be some garbage, rubbish information. We are not going to touch them. So, right? These are going to be those values. How about the next part? Anybody can tell what is happening here? Yes. Yes, Lucas. Where do we locate it? Where do we place, guys? As Lucas said, Reza, what we are gonna do? What is x? Anybody can tell? 0, 1, 2, 3, 4, right? One bonus mark because you said it. Okay, 0, 1, 2, 3, 4. Multiply what, Lucas? 10. What I cannot understand is that part. Hey, come on.
So why should you bother saying out one? Simply say y is equal to, right? Why not right? Whatever it is, we're gonna replace. That part is mine, it's on me, I'm gonna solve that issue, it is going to work, that's not an issue. Okay?
Anyone?
Guys, this is a real concern. Look. I say, instead of saying out y, simply say y is equal to that. Why should you bother just saying, multiply that and put it out into y? Whenever you say that, now, if you say y is equal to something like this, first, it goes to the right side, does the calculation of multiplying those two numbers, put it inside a temporary array. That is a cumbersome process. Means that first temporarily move this, and for such a kind of tiny, teeny array, it's not a big deal. But what if we have millions of records? You know what I'm saying? If you say the result of something, you have to place it somewhere else, means that calculate this row, place it the temporary array, calculate this one, and when it is the whole array, then it's going to be hitting and then bring it to, okay, why? Means that you are going to do something 2 times. Look at this one.
By the way, I shared the videos inside the Telegram I received that question, Reza, when are we going to have the the Jupyter Notebook file after we finish NumPy's chapter? I'm gonna share it. For now, people like to try, so let them just try and see their errors. Here it is. The thing is, rather than creating a temporary array, which happens when you say y is equal to something, you can use this to write computation results directly to the memory location. So when you say 2 out 2 means that bring it to directly. Don't use any temporary when you use this one. And the beautiful part is you can play around with it, saying that, for instance, now, we could say that 0 is 10, and you have 10 values, but you calculate, and your calculation has just 5, for instance, elements. You can say put the power, 2 to the power of x, which is 2 to the power of 1, 2, 3, 4. 2 to the power of 0, 1, 2, 3, 4. Then place it in every other element of y. Isn't it beautiful? So you can even say that in every other element of x. Yeah, any question, any concern? Look at this one. It says that this doesn't make much a difference for such a small computation, but for very large arrays, the memory savings from careful use of the out arguments can be significant. Something in programming is similar to our real life. You may say, hey, who cares? But when it comes to, for instance, paying $1 here, $2 there, you see at the end of the month, it's going to be lots of money, right? So the situation is worth, sometimes you see that like 5 seconds compared to 2 milliseconds, 1,000 or 2,000 times faster. Or now let's go to the aggregation functions here, and they are like aggregation functions that we have in SQL. Let's have x equal to NumPy a range 1 to 6.
What if you said numpy that add reduce? Anyone has any idea? Matthew, your battery is low now, right? Because at the beginning of the class, you got all the bonus marks. Okay, how about this? Another bonus mark. Yes, Lucas. What are the numbers that you're gonna add together? Excellent. 1 and 2, 3, 3 and 3, 6, 6 and 4, 10, 10 and 5, 15. And that's why the result is like that. Lucas, keep doing what you're doing. 1% bonus mark for today so far. Awesome. Let's go to the next part. How about multiply? Anybody can try that? Multiply. Say multiply dot reduce. Say Sheila, don't worry. What is the multiplication of? Yes. Good job, man. 2 bonus marks so far for today. Awesome. Guys, just double check your bonus marks, and next week, if there's anything, for instance, every bonus mark is 0.25. So now it's 0.5. If there is any problem, and I think that happened before, people come to me and say that, Reza, we had that problem, right? And it's based on a trust. Whatever you say, I accept. What is this one? Accumulate. Good guess, but let me just ask you why. What is this? After. How about this? Do you want to pass it to someone else? Okay, so first and second Matthew. Yes. H-U-Y, right? Yes, please. Excellent. And Matthew, do you want to say it again so I can understand it better? Okay, guys, you see that there's one thing. Let me just tell you one solution. Well, there are 2 ways that we can pass these 3 hours. In general, you see some of our friends come here, and if you think that you can find AI, data science classes later easily, not very easy. And I'm telling you, I have been in many classes before. So now we are here, and if you want to see that time passes like this, the only way is just participating actively, like our friends. Anyway, as Matthew said, when you say accumulate X, it means that 1 and 2, 3, 3 and 3, 6, 6 and 4, 10, 10 and 5, 15, right? Look at this part. It's like showing the steps instead of reduce that does the job. It shows you the step by step of the process. How about use this one using multiply? And tell me the result, please. It should be 1, I guess. The next one should be 10 or what? Do it. Excellent. Who else? Brian, did you solve it too? It's gonna be 1 multiply 2, 2 multiply 3, 6 multiply for 24, and 24 multiplied 5, 120. That's easy, right? Because you say multiply 10 divided by 2. Okay, let's go to the next part. I didn't get what is happening here, so a fast bonus mark for people who can solve this. Read it. Let the boy talk, please. What happened?
If you have.
Okay. So if that is the case, and then it's going to be 1, 2, 3, 4, 5, right? And because we say what? Another multiply, another, it's going to be like this: 1, 2, 3, 4, 5, right? In that case, the output should be what? 1, 4, 9, 16, 25. But you got that shows, but wait for the others to use the opportunity. Meha. Yes, Lucas, second and third, especially those who, yes.
This is, again, for this, you take the sequence of numbers in that way, and you multiply the first row by the 1, the second row by the 2, all the way up to 5.
Thank you, Lucas. Awesome. And Enes.
So basically, it returns a new array. Where each element is the product of the corresponding element from 2 of the XX.
I like that. Awesome. Bravo.
So if we just consider the first column, we just
Uh-huh.
first of all multiply to 1, and then it makes the second column. But and then again multiply to 2, it makes third column. Multiply to 3, it makes fourth column.
Awesome. Bravo. Exactly. It's like using it's like it's gonna be one column and it's gonna be one row here, like multiplication table. So you're gonna just say 1 times 1, 1 times 2, 3, 4, 5. You're gonna do the same thing here. Exactly like what you see over. Does that make sense? The thing is to make them it is just to say after. Means that it's gonna just be what we call it in English perpetual. Guys, one it is 90-degree. Perpendicular, right? Perpendicular. The hardest part is converting those math. Math is hard by itself, and then we have to translate it to. So now we get to the broadcasting, and broadcasting is the question that they ask you, right? I said, you remember at the beginning of the session, I said if I have 1, 2, 3, 4, 5, 6, and I say, let's, for instance, I don't know, say plus 0, 1, 2, 3, and I got different answers, and one person said, hey, Reza, actually I tried it and it gave error. But what if, okay, you try that, but what if you try it like this?
1, 2, 3, 6.
It's going to be 1, 6, and the rest is going to be the same.
2, 7, 8.
Seriously? What is the logic behind it? I cannot understand. And next session, we're talking about this one to understand what is the logic behind it.
Every time adds the number on the right side to each of them on the left side.
If that is the case, why we cannot use when we have 2 columns?
when we have two columns, why it doesn't work in that case. Just think about it. So how about this? If we say min, max, guys, I try my best to get to the point that I explain the things that you need for, whatchamacallit, for the assignment. So min, max, and everything between. What does it mean, everything between? Everybody, please try this. Import numpy as MP, and then L is equal to numpy that's random dot random 100 and sum L. What do you think your computer should show? What is the range? Try it.
It's gonna generate 100 random numbers and it's gonna show the sum of that 100 numbers.
Okay, but try it and see what is the range of the number.
47.26.
For Negin, it is 47. What is your number?
Different.
Yes.
Is it gonna be error?
No, not no error. Yes. 51. Negin 47. Donald 51.
44.
Really? 40. Yours is 44 as well. What else? Okay, you see that the range is why we have that range around 50. The center is 50, right?
Yeah.
Why? Anybody has any explanation for that? Okay, Mr. Wright. Carl, look at this one. What is any random number range? No, one, just one of them is between 0 to 1. Right? So sometimes we are not very much lucky, the number is close to 0. Sometimes we are lucky, the number is close to 1. But the average of 100 numbers between 0 to 1 should be something in the middle, right?
48.
For instance, 48, 51 or something. Does that make sense now? Okay. We have sum of L and we have another way. We have MP dot sum L. And they both should give you the same result, right? Which one do you prefer? Mr. Raleigh, what do you think? Just say, do you like to use Python version or NumPy version?
No.
I like to use Python version. Is there any, first, maybe you say, hey, there's no difference. That's option 1. Maybe you say, hey, Python is better because, maybe you say NumPy is better because. I want to hear those reasoning. Because? Any idea? Mahir?
Yeah, so the NumPy, I choose the NumPy because it's faster.
Why it is faster?
Uh,
We don't need to do type checking. Okay, so that is why if you have a chance to look at this, it says that because it executes the operation in compiled code means that we don't need to have that type checking. NumPy's version of operation is computed much more quickly. Look at this one. You can try this and see what, if you say sum big array, and if you say NumPy sum big array, what could be the difference? One of them is in the matter of millisecond. The other one is in the matter of microseconds. So almost, you can say something like 300 times faster. What is this? So everybody try this and see what are your numbers. Check with your neighbors. Does it have anything to do with your computer processor? Seriously? Remember, we are doing these things on cloud. Colab. Then it has, yeah, things to do with the configuration of the server. One question, I very much like to say true and false. The sum function and the NumPy sum function are identical, true, false? Okay, you see it here. Let's go to minimum and maximum. Correct, I'm saying that you see it, that I emphasize, I said, hey, look, math shot. Another one is, yeah, why not? Okay. What about the next part? We have min, we have NumPy min. The same result, right? So whenever you are done with that, just give me a signal, then I can go to the next part. Done, done, okay? And it says that NumPy aggregates a shorter syntax. Look at this one. Everybody, please try this. Say NumPy.random, random 3, 4. It's gonna give you 12 numbers, 3 rows, 4 columns of random numbers between 0 to. This is something that people always make mistake, and I want to give you some hints. Whenever you are done, give me a signal so I can just go to the next. Thank you, Marshi. Wasim. Awesome. Okay, I want to calculate the sum of each column. What do you think I have to say? Sum x is equal to 0 or equal to 1?
Sorry, what?
I want to calculate the sum of this column, the sum of this column, and the sum of this column. It's all about every single column. Should I say x is equal to 1 or 0? How many of you say 1? 1, 2, 3, 4, 5. How many of you say 0? Okay, look at this one. To remember it forever. That is something, the reason that we have 1, lots of people who said 1, it's because we have come from other languages. Here it's slightly different. Here we have to say, we are going to calculate the sum of this column and put it into one line. The output would be line, right? So that is why we say x is equal to 0. 0, because we add 1 row. Again, 0 because we are going to add 1 row, right? And the other thing is, if I want to sum all these values that we have here into one column, well, technically you already know what should be the answer. We are going to have another column, right? Look at this one. I'm going to write, I can see my mouse. Okay. Guys, what is this one? Do you see one here? So whenever you want to have one column as the result, always remember column is equal to 1. The output would be in one column. Everybody agree? So this is how, right now, I don't spend any time to say 1 or 0, but at the beginning it was hard for me as well. So that is how I solve it. Some people say, whenever you want to say 0, is that this one is going to collapse down, calculate the sum and collapse down into one row. That's the way that some people explain it. So it says that technically it means that I want to have my result in axis 0. This is the explanation that you can find. And look at this. It says that the way the axis is specified here can be confusing to users coming from other languages. We already saw that. Dimension of the array that will be collapsed. This is another explanation. Okay. So it says that aggregate functions, we have numpy.sum, product, which is multiplication, mean, standard deviation, variance, and so on. But we have something a bit different, and that is this one. Nothing is new. Yes, I've missed that. Let me just find it because I missed one topic. I'm going to show you in the. Imagine that I add two numbers. Big array, small, not a number. Okay, here it is. Yeah, actually, that's exactly what I passed it several times and I couldn't see it. I need 1 hour break for sure. Look at here. It says that sum and numpy, not a number sum. What are the differences between these two? Yes, Lucas?
Yes, depending on some, can accommodate one of the values in the index is not appropriate. I think I just skip that and continue summing versus for any sum would be set to that row there.
Apart from the fact that you got 1.5 today, I'm curious to know something, if you don't mind. Did you study in advance?
So, I mean, I did a different program.
Because I don't believe in accident or chance or something. I never do. No success is random or the result of random things. Yeah. Awesome. So let me just show you this here. Imagine that we have 3 numbers, like 1, 1, and 1, and not a number. If you say sum of these numbers, it says that, hey, I cannot understand. Not a number is our result. But what if you say, hey, you know what? Those who are numbers, add them together and ignore not a number ones. This is not a number sum. Does that make sense? Where do we use that? The time that you have not a clean data set, means it has noise and it has some gibberish characters. So you're going to just say use not a number sum, not just only sum. That's one of the use cases that we use this. Yeah. Look at the next part. We are just at the beginning of this, which I'm very happy that we could make it all the way to this part. And the data set for this one is available on the net, so you can just check. But if you see from here, I said import numpy, then I said import pandas, and then I said use read CSV file and place the content of that into a data frame. It's exactly like assignment number 1. these lines are identical to, yeah, what you need. And then say data.head, it's gonna show you the first 5 rows of the data set. And then you say, okay, you know what? We have all those columns, but I just want height based on centimeter. So I say the data, go to that specific column. Does that make sense? And then you are gonna calculate mean, average, standard deviation, mean and max. Who had a chance to work on the assignments? Okay, guys, are these steps are familiar for you? Okay, by just reading that part, how much do you think that we could cover assignments? Okay. Okay, guys, what I want to say is you already have, listen to me, you already have 60% by just reading. I just started, I didn't complete. By going through this, and it's just 2 pages, you see, and just show the graph, as simple as that. By just going through that, you almost, based on your friends, I didn't want to give you any number to, because I'm biased towards. I think that it is very simple, but not necessarily. I don't think if you are even new into Python environment, it takes more than 1 day. You have this, please read them, and then start working on the assignments. And the good news is, next week we are gonna continue working deeply on this concept. That's the first thing. Second, we have labs, so you can bring your problems, your questions, and you have time till Friday, am I right? Still tons of time. I think it is reasonable, right? By saying that, now it is 1:51, guys. Thank you very much. Have a wonderful one. See you next. That's a day. Stop recording.